Installing local models on your personal computer is easier than you think. No complicated setup required, no Python knowledge required, and no coding experience is required. In just 3 steps, we will have our own AI model running on our PC, completely private, no subscription, and no limits. LLM is short for large language models. And here's the fun fact about LLM. All these models were initially trained only for the language that is text. But modern models like GPT, Llama, and Gemini are multimodal, which are trained on images, audios, and videos. But the core engine is still the same. So name kind of stuck with them, which is LLM. Now the newer models are also called LLMs. Let's start with our installation. Step 1. Go to ollama.com/download and click on the download button based on your computer operating system. And that will start the setup file download. Let's discuss something important until the file downloads. First thing, how these local AI models works. Think of Ollama like a game launcher. But instead of launching a game, it launches AI brains. Ollama helps you download and run AI models. It does not create the models. Instead, it gives you super easy access to install them, store them, and talk to them. Let's have a quick look on Ollama architecture to understand it better. The first layer is user input layer. This is where everything starts. The user asks the question or a prompt. For instance, explain gravity. This text is sent to the Ollama app. Next layer in the architecture is called Ollama CLI or UI layer, which is command line interface or user interface. This is the interface we interact, either using the command terminal or we send the prompt from the Ollama app. The next layer in the architecture is called Ollama server layer. This is the brain of the Ollama app. It runs on our computer at 11434 port, and it handles loading model, managing memory, receiving prompt, sending responses, and streaming tokens. Think of it like a traffic controller. Fun fact about the ports. We have around 65,000 usable ports in our computer we can use. This is like connecting to the Ollama app on our computer through door number 11434. Now, next layer in the architecture is model registry and model files layer. Ollama stores model files in our computer. Each model is a GGUF file. GGUF stands for GPT generated unified format, which contains model weights, which are billions of number, vocabulary, tokenizing rules, and metadata. Think of it like an actual AI brain file. Fun fact, we all use GPT, and here's what it means. G stands for generative, which means it can create new things. P stands for pre-trained. It learns a lot before it meets you. And T stands for transformer, which is a special brain designed to understand our language. Next layer in the architecture is load model layer. When we run a model, Ollama opens the GGUF file, loads the weights into the RAM or VRAM, allocate memory for the inference, and process the model for token generation. This is like waking up the AI brain in the process. Now, next layer in the architecture is called Tokenizer layer. Before model can think, the text must be converted into numbers. The tokenizer breaks the text into tokens, convert the tokens into IDs, and sends them to the model. This is like a translator in the process. Next layer in the architecture is Inference Engine. This is the core math engine. Ollama uses llama.cpp, which is written in C++, and it is optimized for CPU, GPU, Apple Silicon, NVIDIA CUDA, AMD, and likewise. This is like a thinking machine in the process. Now, next layer in the architecture is hardware acceleration layer. Imagine we have to solve 1000 math problem. CPU is like one kid solving them one by one. GPU is like 1000 kids solving each one at the same time. And that is where GPU is 10 to 50 times faster than CPU. If GPU is available, Ollama uses GPU. It is much faster, it can handle larger models, can do parallel processing. When no GPU is found, Ollama uses CPU. It is slower but works on all computers. Ollama automatically chooses the best hardware available on the computer. Now, next layer in the architecture is token generation loop layer. This is where model generate text one word at a time. Model predict next token, Ollama streams it to the user, Loop repeats until completion. This is like a speech generator. Now, the final layer in the architecture is Ollama sends the generated token back to us. This could be either terminal or app or API client or browser. This is like a speaker in the process. Let's go back to our installation and continue with the step 2. Once the download is complete, double click on the setup file and the installation will begin. Once the installation is complete, app will open on its own. Until the installation happen, let's decide on which model we are going to use and how do we decide which one to download. For today's demo, I choose Llama 3.2 1 billion model. The reason is it is very lightweight, only for 1.3 GB in size, and it is a text-only model. It has 1 billion parameters and can be used for personal information management. Multiple language support is available. Rewriting tasks can be performed very smoothly on this model, and you can write stories with this model. And the response is really very fast. Now, before we continue, let's have an insight on this model file, what it actually contains. Here's the sample model file to understand it better. The first part of the model file is metadata, the identity and blueprint of the model. This section tells the system what model is, how big the brain is, how many layers it has, what tokenizer it uses, and how many words it knows. Metadata is like a master plan. Everything else in the file must match these numbers. For instance, if metadata says 32 layers, the file must contain 32 weights. If metadata says vocab size is 50,000, the vocabulary section must list 50,000 tokens. Metadata is the glue that ties all the sections together. Then comes vocabulary. Words the model knows. This is like the list of all the words or word pieces in the model can use. The tokenizer uses this list to break down into tokens. The embedding weights must have one row for each token. So if the vocab size is 50,000, the embedding matrix must have 50,000 rows vocabulary. Then comes the tokenizer merge rules. These rules tells the tokenizer how to combine letters into tokens. When we type gravity, the tokenizer uses this rule to turn it into tokens. These tokens map to token IDs in the vocabulary. Those IDs are used to look up the embedding weights. Then comes the model weights. Model weights are the actual brain of the model file. These billions of numbers are learned knowledge of the model. Weight depends on metadata, vocabulary, and tokenizer. Weight are the thinking engine of the model. Next layer is quantization info. How this brain is compressed. This section explains how the weights are shrunk to make the file smaller. Next layer is special tokens. These token defines the beginning of the sentence, the end of the sentence, or any unknown words. Inference uses them to know when to start and stop generating model. Let's move on to third and final step. Once the app is downloaded, close the app and start it again. This will reset the app cache. Click on the model drop-down and start typing llama 3.2 1b in search and select model. Then simply type hi in the chat and click send button. This will start downloading the model on our computer, and we can start chatting with the model once the model download is complete. This model is very fast, but you can explore other models as per your need. Let's have a look at the app setting. You can enable cloud models, but they cost money to use it. I usually disable the auto update and expose Ollama to network. You can explore model files in the model location. We already discussed this before. Context length is important to know. Context length is the maximum amount of text a model can remember at one point of time while generating the responses. The Llama 3.2 model supports up to 128,000 token context length. That's all from me. Tell me in comments which model you downloaded today. See you and have a great day ahead.